topic today, and our two presentations today have to do with open source software and geospatial information. So let me explain a little bit of how this is going to work. I'm sure you know we'll have 20 minutes for each presentation, followed by a question and answer session right after the two presentations. And in the process, or while they're doing their presentations, we're going to be handing out formats for your questions. And please include your email so that if we're not able to get to your question because of time limits, then we can send you a reply via email. So to begin, I'll read you the CV for each of our presenters. So we'll start with Álvaro Anguix. He is a topographic technical engineer. He's managing director of GV-SIG Association, and he has had several articles and published in magazines such as Fundamentos de las infraestructuras de datos espaciales, and in also Directions magazine, GeoSig, a GIS desktop solution for an open SDI. This is an article in the Journal of Geography and Regional Planning. Also another article that appeared in Mapping number 125 for May 2008. Another one opening that's discovering the open GIS world, and he's had many other articles published. He's participated in various international and national geography-related events, the 8 editions of the International GV-SIG conferences in Spain, also the conferences on spatial data infrastructure that also occur in Spain, as well as many other conferences. Welcome, Álvaro. Then we'll continue with Carlos Raúl Montaño, who is a PhD in water science and technology. He obtained his doctorate at the Mexican Institute of Water Technology. He also has a master's in computer science, specializing in computer networks from the Monterrey Institute of Technology. And he also has a master's in watersheds and also in physics and mathematics from the National Autonomous University of Mexico. He specializes in computer science also from the UNAM. He is now Deputy Director of Geodatabase Management and Webcasting at the National Water Commission. He's also participated in many events with conferences on droughts in Mexico and how they are managed, and also, for instance, advantages of working in the water quality system. And he's also written many articles regarding also how do you implement a geodatabase, and he's done this all for Conagua. So we'll begin with Álvaro. Well, good morning to all of you. I'd first like to thank the INEGI and the United Nations for giving me the opportunity to be at these conferences. And I'd also like to congratulate you, INEGI, of the path you've taken towards technological independence. And these conferences have given me the opportunity of coming to Mexico for the first time, a country where a constitution includes social rights. So I'm going to talk about GV-SIG from a point of view not that you're probably used to when you hear lectures on this sort of thing, but not from the point of view of the users or even the developers, but from the point of view of those the decision makers, the strategic decision makers in organizations. The title of my presentation is what do we want to bet on in terms of development? Well, so the first thing is to introduce oneself. So I'm going to tell you a little bit about GVSIG. So we can say that it is the biggest network of free geomatic specialists. We have projects in several countries, despite the fact that we're young. We were born at the beginning of 2010. We've had projects in, you can see there, Germany, Argentina, Brazil, Ecuador, Spain, Italy, Kenya, Mexico, Uruguay, Venezuela. We have references in in very many different fields, from IDE and petroleum exploration, for instance, for PDVSA, to projects as GVSIG Batovi, which is developing software for primary and secondary schools in Uruguay. We also have worked for international organizations such as the United Nations for GIS analysis for urban settlements, and definitely we are a conglomerate of identities of universities, companies, over 40 companies from all over the world, and also NGOs. We also have an online learning center, and we have with more than 1,500 students registered in over 40 countries. But you may still wonder, well, what about GVSIG, the association? What exactly is it? Well, our objective is to get going a development model, a software development model, which we could also say it's a production and business model, that will enable, with free software that's going to exchange information and share information, that will enable people to produce more, better, and more fairly. So it's not just a question of free software, but it has to be better and more. There has to be more of it. Our activity is geared to designing the best solutions for the client, offering the best guarantees. And you may ask, well, how do you do this? Well, through the transfer, the absolute and total transfer of knowledge. In other words, the client is the owner of his or her solutions, or its solutions. It's the only way of ensuring it. You may wonder, well, how is this possible? I already have my black boxes with products that have limited licenses, user licenses. So how do you do it? Well, it's possible thanks to free software that is not hidden, that is not closed, and it has no limitations in terms of use. These possibilities are the rights of the client. You are going to be free to use, to modify, and to distribute the technology with no limitations whatsoever, with no restrictions. And in terms of maximum guarantees, why did I mention this? Because we're amazed in a stock of free products that is broad, powerful, and mature. Today, we can take on the most complex product using 100% free software. What we do with this stock of solutions is we adapt and develop based on these products, and we provide solutions for the client's needs. And we deliver to the client the entire product. What does that mean? Well, the binary, the source code, and the documentation. That's what we deliver. And therefore, that's how the client is the owner of the solution. That's the only way they can be the owners of the solution. So I'm not going to stop talking about us, and I'm going to make some comments now. The first thing I'm going to say, I don't know if you've heard of FUD, which is fear, uncertainty, and doubt, which is promoted by some transnational software companies, and that all of the rumors that have to do with free software, that it's no good, that it's guilty of it's raining over the week on weekends. But let's be serious. When we talk about free software, and when we talk about software from a technological point of view, there are only two. There's good software and there's bad software. And whether it's free or proprietary, the type of license, what it's talking about is the conditions of how we can use the software, and that's are provided by the copyright. The free software, as we said, has absolute and total access to the knowledge. And in terms of quality, what we can say is that if what there is doesn't solve your problems, if it's free, you can solve it and you can find out why. But if it's proprietary, well, pay for it, then cross your fingers and hope for the next updated version. That's what we say in Spain. Also, talking about quality, we have to be aware, reasonably aware, that the only way of getting to know the quality of a software is accessing its source code. Now, I said that I was going to talk about any basic user manual, which is for business administration, will say that if our organization, we make it dependent on just one supplier or one provider, then we have a manifest weakness. With proprietary software, we are making the heart of our organizations dependent on just one provider or a proprietary provider. So think about this and remember the problems that you can have in your organizations with proprietary software. I'm sure that if we were to talk about that, we could come up with a lot of problems that some of you have had. So I think today is October 8th of 2013. We're in the middle of the 21st, or fully into the 21st century. And I think we should all ask ourselves, should the use of free software, should that be a priority decision, a strategic priority decision? And I think it's important that we need to answer this question. So now let's talk about GVSIG technology. Well, GVSIG Association, on the one hand, we develop our own technology, in other words, GVSIG brand, and we use the entire ecosystems of free geomatics to implement our system. So why don't you do a map server? Because when there are free, very powerful ones that already exist, and the same thing for databases, etc. And what we do is collaborate with these projects and use them in our services. And we implement 100% free solutions, and or mixed. And I'd just like to make a comment that when we go to mixed solutions, the guarantee of interoperability is not provided by standards. And interoperability, it's important. When we say interoperability, we mean that we can change the pieces. So it's important to work with free standards, OGC, etc. And we also develop corporate solutions, sectorial solutions, different sorts of solutions. So now here, this is simply a slide with the logos of some of the technologies that we work with. GeoServer, Map Proxy, GeoServer, Map Server, Open Layers, GeoNetwork, etc., etc. So very often, internationally, it's almost these sorts of software, this software is used more than proprietary software. Now, in terms of our software, probably the most well-known is GVSIG Desktop. If I say that is one of the most powerful SIG, you may not believe me all the way. But I'd like to put this paragraph from an organization. It's from the National Geospatial Technology Center of Excellence. And you can see that it says GVSIG has nice vector data, editing functions. Users can easily digitize lines by snapping vertices etc., etc. Its main features are it's multi-platform, it's multi-language, it's easy to use, it's user-friendly, it's customizable, and SIG plus the client ID So what we're saying is that what we make it easy to implement whatever the client, and it satisfies the needs of the client. So the interface for the desktop or GVSIG, I'm just going to go quickly through the slides because we don't have a lot of time. You can see a lot of the documents, the maps, the tables. These are vector data. I'd say that GVSIG meets the needs of 90-something% of users because it has everything, query, symbology, access to most of the vector formats that we're going to work for, KML, etc., and also free databases as well as proprietary databases such as Oracle. As far as infrastructure of the spatial data, we have all sorts of, we support lots of different standards, WFS, WCS, Gazetteer, etc. And there's also a lot of publications. And all of the things that has to do with tracking and teledetection, GVSIG doesn't have the same power as it does its vectors, but it does have the main functionalities that are needed most of users. We work with main tracking formats, JPEG 2000, et cetera, and these are some of the tools that you can see there. We work with color tables, vectorization, referencing, and classification. In terms of additions, we try to approach what is a CAT program. You don't need a CAT program or rather you do need one, and then SIG for analysis. These are alphanumeric editing tools. These are screenshots. This is advanced symbology, and also the labeling, for instance, advanced labeling. This is advanced geoprocessing. Here, SIG is very complete because we also use tools, external tools, and I think there are more than 400 processes that are available. So the rarity would be if you didn't find the process that you needed to work with vectors and so on. This is the typical table and chart handling with field calculations. I'm sure you all know these tools. And this is layout, which is to design the graphic visualizations, and either to print or PostScript. Now, it's interesting to know that there is extension to generate GIS maps. And also to say, aside from GVSIG that you did download, there are a whole bunch of other options that you can also download freely that enable to add functionality. Here you can see a screenshot of Network Analyze extension. So you can analyze the topology, and you can calculate optimal routes, and also it's very applicable to geomarketing. That has to do with influence and distance and travelers. This is another extension. This is an animation extension that will enable us to work or add two types of documents to GVSIG, which is animation, which can be in 3D. And also we have two types of 3D visualization. So here you can see buildings that has functionalities geared to 3D. And this is simply say that for 3 years we've been working for the growth of the project, and we have more functionalities and more functionalities, and we've evolved our architecture to be able to scale solutions in the future. This area is the one we call GVSIG 2, and we released the 2.0, and we said that it was a new GVSIG, and therefore it wasn't for working in production, but simply a beta version to try to start seeing how it works. But by December, we'll be out with 2.1, which will be a version for working in production and which migrates almost all of the functionalities that we had in 1X. And also we've developed new functionalities that could be very interesting, such as street maps, an import of automatic symbols to generate libraries. And we're going to have those, all sorts of libraries. We have document graphics. For instance, you can see there the word Python. We have a scripting language. I've said that GVSIG has developing Java, but we have also developed it in Python. And we're going to be publishing very soon a repository of Python scripts so that people can have examples or samples to learn and so on. And it's very interesting. The version 2, we have a complement administrators or an add-on administrator that will enable us to add on any updating or extension without doing anything, just as you can say in Firefox or whatever. So this is an area that's going to be in the future, and that I think very soon we'll be able to see a product that is very, very powerful compared to the current GVSIG. And this version, talking about development architecture, is based on very small components with a very small core. And this enables a greater sustainability and greater agility for the different versions, but also to have a customized project, not just for desktop, but also web, on the web. So we're applying part of the GVSIG code to calculate for a portal, a multimodal portal, for instance, with root calculations. These are some other products, GVSIG Mobile, which is for wheelwork, and that's geared to mobile devices with some of the functionalities that you can see: symbology, visualization, labeling, GPS support, editing, selection and search, etc. These are some of the images of the mobile, and so that you can find see some of the other products that we have. It's a very the Educa, this is the educational product, which is very interesting, and we used it with the government of Uruguay, and it's very interesting because what they've done is that within a desktop for kids, and all of the computers, the desktops, obviously there's a much simpler GVSIG. We've eliminated some of the tools and made it more educational so that kids can learn about geography directly using free geographic software. I don't remember the number of students in Uruguay, but I think about if they had to pay for license, it would be unfeasible. These are sectorial solutions. This has to do with roads, and it will be available in 2014. This product is a GVSIG that's applied to roads with functionalities, not designing roads, but the functionalities has inventory, accidents, the automatic generation of reports, and street plans, the generation of road plans, dynamic segmentation. And in this case, the proprietary products were very expensive and very limited in terms of functionalities. And what we're developing with projects that are already up and going is a free GPL product that covers these expectations. And I hope that more and more countries will join in this project. And some of the areas that we're working on have to do with cadasters, with cleanups and supplying, criminology and crime mapping, everything that has to do with water management, with municipal administration, with tourism, health, defense, etc. So this is the GEO framework. and I'm going to be talking about this for the first time. We're doing a project, a very large project for Venezuela's oil industry, and you can imagine it's a huge organization. And what we're going a little bit beyond spatial data infrastructure. And what we want to do here is come out with a product. We have a similar one in another, we have a similar product in Spain. And one will be in Java and the other one will be in Python. Because when we talk of corporate solutions, it's important to have at least 2 programming languages, because organizations that only depend on one can run into problems. And I'd like to say that the geomatics, we have to see it as a technology, a particular technology that has to be integrated into information systems. And we don't always see this. Spatial information provides an attribute, a particular attribute, yes, but it's just another attribute. And it's true that not too much information has a spatial character, but we shouldn't produce isolated applications that are difficult to sustain or maintain. And the systems have to be interconnected, or they should be able to talk to each other. So, and the IT in an organization should evolve in conjunction. So that's another objective that we have, is that the geo part should be completely integrated into an organization's IT, that the common parts of an organization should be standardized. And a geo framework, we don't have a name yet for this product, but it's a set of components that enable developers to generate applications in the most agile way possible, and reusing code and making maintenance, facilitating its maintenance. So this is a little bit what I want to talk about. This will be coming out next year, but I think it's interesting, since there are people here from very large organizations, that you know about these sorts of solutions, because right now in free software there wasn't something quite like this. And then finally, I won't take any more of your time. This is what about the impact of the model that we've been talking about? There's a tool called Google Insights. I think it's called, they've changed the name, but it measures trends. And here you can see a search comparative of GVSig with the most well-known SIG proprietary GIS. As you can see the trends. In 2008, GVSig was already surpassing the others in terms of searches, how many people searched for it. So it's now translated into over 25 languages. It can be downloaded in 90 countries. We've had over 100,000 direct downloads. And then for me, what's important are the GVSig events that are organized not by us, but by other people. We organize the ones in Spain, but that's it. The other ones, you can see that there have been other organizations that organized them. In 2012, for instance, there were 4 in Latin America and the Caribbean, 2 in Uruguay, 3 in Brazil, 2 in Argentina, 1 in Chile, and 1 in Chile. We have online training portal or website you can which you can access freely. This is also interesting. These are case studies where users send us their information and their reports, what they're using GVSig for and what problems they've had and what are their solutions. And you can search it by category, by sector, by country. And there are hundreds of case studies and success stories too. These are some of the geographic communities. We see GVSig not just as a community of users, but also by country, because each country has its own particular way of using technology, and that's why we try to promote the creation of geographic communities that they organize, that they hold events. And just tell you, they're going to be 2 days, the Latin American days, that's going to occur in Buenos Aires, and then the International Day, which is going to be in Valencia. And then in conclusion, just a final comment, which I think this entire presentation can be summarized in one sentence, which is, in technology, the client satisfaction occurs when the client controls its technology and does not become its slave. Thank you very much. Okay, thank you for your presentation. Thank you very much to all, and I'm very grateful for the invitation. The management of open source software in terms of information, geospatial information, as well as proprietary software is very important depending on the situation of the client. In our case, which is the National Water Commission, we have a particular focus in how we manage water resources. So I'm going to have a presentation of what we do at CONAGUA, which is and then we'll talk about all of the tools that we use. The next slide, please. Well, the National Water Commission, or CONAGUA, has a very difficult task, especially in the terms of managing water resources. Our objective for 2013-2018, one of our basis of objectives is obviously to reduce as far as possible the effect of the climate change on extreme weather patterns and extreme weather events, and such as what has just happened on the Pacific coast. In our case, it's something curious happened. We are really at the extremes. If we have too much, a lot of water, there are problems. But if we don't have enough, we also have problems. So in essence, we're working in the middle, believe me, is very, very complex, because we find ourselves at both extremes. So one of our challenges is to ensure that natural resources are sustainable. Article 25 of the Constitution of Mexico mandates that we generate a system that helps what I was just talking about, in other words, a sustainable development. As I was saying, the problems in our country are very complex because of the climate. We have floods, we have drought, so all of this will necessarily means we need to be able to have a technological platform that will give us information quickly, on time, or at the right moment, so that users can access immediately and make it for making decisions. So, what was the solution that we implemented?
Information was generated by static files that were in a shape format. Let's say that is a common term for many of us, but the information was fragmented. So we tried to do it in a different way, integrating through a platform that was robust enough. And we started to work on a geodatabase, integrating all the information. For a national territory, however, the problem is different depending on the different sectors. So what we did was to try to see the opportunity for generating distributed databases such that each one of our bases and organizations in the different points of the Mexican Republic will have access to that information. That is, that everyone could have access to the same information, however, being supported by decision-making processes in a local fashion. So this is what we saw, that we had to handle it both as a whole and locally. And this is how we distributed databases. Then we ran into a staffing problem. What happens with the equipment, staff, and other requirements? We started to see or adapt the investments in a smart way. So we started to work on elements that could have massive storage information that would handle greater volumes of information, considering the accuracy that was required through different studies in different parts of the territory. However, as I said, we also had a problem with the staff. Not only the software, but all of this entails their own investment. So where should we invest? In hardware, software, staff? So what do? Then we had to balance all these elements. So the option here was thinking about virtualization. What do we do? What do we do? Well, we had virtual equipment that would allow us to have computers, or something working as a computer where we don't have actually a computer as so. So it allows us to generate, not physically, but virtually on a software platform, which makes some consultation processes faster. So in some basic institutions that are distributed in the Mexican territory can have access to this information and check the databases giving solution to their own needs of information. So this is also connected and centralized, and you can see it also at a general level. So we require these platforms that were not directly with or closed source, but using open source, and we start to work with some elements that would allow this access to be simple. So we thought about some possibilities to virtualize equipment with open source, with VMware, for example, in this case. And our development platform was our GIS. And we decided to use with app tools in this case. Well, we wanted, of course, to be more cost efficient, and then we wanted to work with the best of both worlds. So if there is the software and you have to acquire the license, on the other hand, we have an open source, why not using them both together and having the best of both? So we integrate them through a standard and through a communication protocol. And what I am referring to is the integration of elements. And this can be generated with interoperability and from an element that comes from a structure or information processing structure, nodes, and REST. That is what I'm going to present now. Now, this REST specification, what is it? It allows those elements that have been programmed in the platform that existed from the beginning in the organization, so as not to discard, for example, if you have the federal government and they have many expenses in order to decide what to invest on. From their point of view, and I put that to your consideration, would it be necessary to reinvest in something that they have already paid, I don't know, 100,000 or several millions of pesos for a platform that is already in operation? We will have to decide where to invest. So why not to adapt this to the current needs through newer platforms and not making such a big investment, but with more flexibility to the actual option. So this is where REST allowed us in the geo database that already operating, integrating each of these elements. And there was another problem, the difference between the models with the REST specifications and what the swap would be directly in handling this tool linking. So in this case, this would allow some management of API elements. The programming interface to these applications gives greater flexibility in such a way that it's not necessary to have so much stored online, but you can offer an affordable product for the user. In some cases, we have implemented tools directly online, and the information has to be integrated directly with what we already have in that geo database that I mentioned at the beginning. So we integrate these two elements, we process, and then the outputs generate a very affordable and easy to use product that is friendly to or user friendly. In our case, Conagua, and in other federal institutions, we have several consultation levels. We have people that are the general population that they may we may also have an inquiry from an elementary school student, and we may have some others from students from other countries, other agencies, and we have all of these different types of queries that we can receive. And this will give us, of course, a flexibility, and we have different options to present the information. As we said, the difference between the tools and REST and SOAP, in one case we have two elements. We have XML. XML gives more transparency to move from one place to the other in terms of programming, but we also work on HTML. HTTP will also allow us to communicate directly to those both and links them and creates a connection. And as I said, we have a discrepancy here between one and the other, and there have been really, really important discussions about which one's better, which one's more useful, what's the more suitable specification. And until recently, we were working with SOAP, but we had a problem. It was not right portable, and it wouldn't give us the access that we needed to the code. So we chose other applications on Flex, Silverlike, and this has produced great results and have allowed us to have access to the information online. So the specification allows us to create a catalog. What you have online on screen is a list or a catalog of services, and this means that the user doesn't have to reprogram what has already been done. They will have access to one of the services and upload this to their cartography that can be operated on an open source program or on a proprietary program. Using any elements, we don't have to reprogram all the services over and over. They're available already. At any moment, you can check this website so that you can download any information that you may require, and this will save a lot of time in the work that you would otherwise need to do. So in this case, we have some online applications, some examples. Deep water explorations, for example, we're working specifically at the federal level to obtain some information about exploration wells, deep water wells. And this tool has been useful to analyze in detail each one of these elements, to have drills in the more suitable areas and get some appropriate samples. We have also done this in other types of watersheds, and we have integrated information at an international level. Each layer, as you can see, has their own elements to have access to the tools and for queries, and they're really easy to use. The National Water Locator uses superficial underground information for the federal wells, and this system has been widely accepted because it analyzes each registration and what is included in the public inventory, so that we can know how much fluid that is assigned any type of concession. Drought monitoring, as we know, we can have floods, but we also have this drought period, so we can analyze them directly online, and we can see how this support is moving forward in each region and how investment is being applied through CONAGUA. So this will not only analyze the geospatial area, but also obtaining an economic analysis in order to see how everything is being distributed and how the information flows. It's also important to say that we're working with different government agencies, and I think it's one of the most important efforts that we have in our country. So we will need to integrate that information from all these government institutions in one interface so that we could consolidate it and have the information available online. Just the same type of information for all users. The potential reserves of water for the environment, this is something important to present this information in the future and to see how much water we may have in the future and handle it as reserves, and have the certainty that water will be available for the next generations in the appropriate way. And then what would be our next step? To work through the specifications we have for software and proprietary software. Through the different schemes of information exchange in order to generate a new interface that will be a geo portal. And the structure is through this database distribution and dynamic links that would automatically give us access to the information to give the user any answers to their queries. They are different, as I said, depending on the user, but they do have a common thing. Information should always be accurate and clear and updated. And in that sense, we are trying to get this automatically, and we are also generating the links with different agencies so that all this information, it has an interaction in terms of operation and the way the databases operate. Like, for example, INEGI, Sebarnat, and our database. You will not see where the information is located, but we would be responsible in this action field to getting all the resources. As a conclusion, for geoservices, we have had really important results with this. And instead of handling many services or a lot of information of database banks, we have just one to link that information. We just have one service list. In this way, we are trying to have a greater distribution. So we have access from one database, and to the future, what we want is to work just with catalogs, service catalogs that could be available for any kind of user. Almost 70 or 80% of these applications are already available in several services of other areas, not even private, and we are continuously being asked to give access to all of this. So if you need to contact me, well, I will be happy to answer any questions. If you need any technical specifications, I will be glad to share them with you. Thank you very much for your attention. Thank you very much. This has been great presentations. Now we open the Q&A session. We don't have much time. We may have time for 2 or 3 questions to close our session on time. This first question that we receive is by Enrique Navarro from INEGI. He's asking, what would you say are the critical factors that generate or that have made GV6 project successful? When we started with this project, there was something that we were concerned about, making it sustainable in time. We had the support of a regional government in Spain, and what we did was to evaluate what was going on in the future. In the world, the rest of the world, there were other projects that we saw with different qualities. Some of them were absorbed by the company that started supporting them, but then they had in the end a system that we wanted to escape from exclusive suppliers. So what we did was to consider both the technological components and the economic components and all the organization aspects and everything, all the politics behind organizing an open source project. So this evolved, and we created the GV6 Association. If there are companies that are generating profits out of this, they should maintain or they should support this project, economically speaking. And on the other hand, we are, of course, working on collaboration, making this a democratic project. It has been a long process, and I would give a whole lecture about it. But it's not only taking care of the scientific aspect, but also the organization that is behind all of that project. The last question by INEGI, Efraín Limones. If culture and language play an important role in this trend of a proprietary or open or source software, yeah, definitely. If I have it in Japanese, well, it will be not useful for everyone. In GV6, we have a lot of coverage in Latin America for many reasons, but mainly because of the language. GV6 produces everything in English and in Spanish, and then it is through different collaborations, it is translated to other languages, but all the initial work, the interface is English and Spanish. I'm going to just tell a story very quickly. The first time that I traveled to Latin America, which was to Venezuela, to the Statistics Institute of Venezuela, they told me that the version of GIS 3.0 was not distributed in Spanish, when in Spain we had it available in Spanish. And this is just an example. When you have a monopoly, there's not much that you can give to the client. So they said that it was much easy to use SIG because they understood the project and the language. Thank you. We have more questions, but I will give them to our speakers. There are some congratulations as well, congratulation messages, and I will give them to you as well. But if you have, please, the little tokens of acknowledgement that we will give to our speakers. We will give this small gifts to our speakers in order to close our session. For Álvaro and Anguix, for your participation, thank you. Carlos Montaño. Thank you very much for your attention.